Okay, we're giving the function f, and then h of x is defined as the integral of f from 0 to x. So h of 5 is the same as plugging in 5 for x. So really, I'm looking for going from 0 all the way to 5. So I need all of this piece right here. Okay, so let's kind of go ahead and do all the separate pieces. I'm going to break this up. So we need to get up to here. So this piece here is just a triangle. So I'm going to do 1/2 base times height. That's going to give me 2. But we are looking for the integral, so we need to count that as a negative number because it's below the x-axis. This little triangle here is going to be 1/2 base times height, which is 1/2. This, notice, is just a rectangle that has an area of 2. And then this is a half circle. Radius is 1. So pi r squared divided by 2, which is pi f. So we just need to add all these pieces together. So I've got -2 plus a half plus 2 plus the pi halves. You can leave it like that, or if you simplify it, you get to pi plus 1 over 2. Okay, local max. Step 1, we need to find the derivative. Where is the derivative of this graph? Equal to 0, or does not exist, but really h prime is f of x, and this graph doesn't have any holes anywhere. Okay, the only zeros that I see on this graph are at 2, and this is exactly 6.5, and I know exactly because it's a straight line, and the slope is -2. So my only possibilities are 2 and 6.5. But I want a maximum, so the sign has to go from positive to negative, and that only happens at 6.5. So we're going to say at 6.5 because h prime of x, which is really f of x, changes from positive to negative at 6.5. Okay, absolute. So first thing is we can only check, we have to check critical numbers, which we already did. But we already figured out that 2 is not a maximum, it's a minimum. And then the other thing that we need to check is our endpoints here, which are going to be 0 and 7. So I need h of 0, I need h of 6.5, I need h of 7. Okay, in this one, you actually do not have to calculate all the values because we know h of 0 is 0, right? Because h of x is 0 to x of f of t. So if I plug in 0 for x, you get the same bounds. And sometimes I'll do it this way first before I start calculating. Sometimes you may be able to just compare. We figured out that h of 7 is a positive number, right? Oh, did we figure out h of 7? No, we did not. Okay, so h of 7 would be all of this. Okay, I can tell that there's more above the graph than there is below. So I know that this is going to be a positive number. Okay, let's look at h of 6.5. So if I actually only stop here, notice if you go all the way to 7, this is also positive, but this for sure has to be bigger than h of 7 because when you go to h to 7, you are going to be subtracting off this piece. So I know this has to be the highest value. Now, it doesn't ask you to justify here, so we can just go ahead and give that as an answer. Okay. I've got another function g, which is f of x times x squared minus 3. They want me to find g prime of 1, so I have to use the product rule here. Derivative of the first times the second plus derivative of the second times the first. Let's plug in 1 for x, f prime of 1. This is going to give me -2 plus 2 times f of 1. F prime of 1 is the slope of this graph at 1. So where's 1? 1's right here. What's the slope of this graph? Up 1 over 1. So slope is just positive 1. And then f of 1 is just the y value of this graph at 1, which is going to be, looks like -1. So this is -4.